Welcome back to PrepForge. Today we cover the foundation of everything you build in AWS, the VPC, or Virtual Private Cloud, and its subnets. Here's why this matters. Almost every AWS system design question eventually becomes a networking question. Where does the database live? How does the internet reach your app, but not your database? What's the difference between a security group and a network ACL? In this video, we'll build a real three-tier architecture, a load balancer, application servers, and a database spread across 2 availability zones, and along the way you'll understand VPCs, subnets, route tables, internet gateways, NAT, and firewalls. Let's get started. Let's frame the problem. You're deploying a web application. Your load balancer has to be reachable from the public internet. That's the whole point. But your database absolutely must not be, if it's exposed. You're one leaked password away from disaster. Meanwhile, your application servers need to talk to that database, and they may also need to reach out to the internet to download updates or call at a API without being reachable from the internet themselves. So you need a private network that you control with carefully placed doors. In AWS, that private network is called a VPC. Concept 1. What a VPC actually is. A VPC is your own logically isolated private network inside an AWS region. Think of it as your own private data center, but virtual. When you create one, you define its private IP address range using something called a CIDR block. For example, 10.0.0.0/16. That /16 gives you roughly 65,000 private IP addresses to hand out to your resources. The most important property is isolation. By default, nothing can get into your VPC, and nothing can get out, unless you explicitly build a door. Every server and database you create lives inside this VPC and gets a private IP from that range. Concept 2. Subnets and Availability Zones. You don't put resources directly into a VPC, you put them into subnets. A subnet is simply a slice of the VPC's IP range. If your VPC is a /16, a subnet might be 10.0.1.0/24, giving you about 250 addresses. Now here is the single most important fact about subnets. Each subnet lives in exactly one availability zone. An availability zone is a physically separate data center within the region. So if that one data center has a power failure, everything in that subnet goes down with it. This is why every serious architecture spreads its subnets across at least 2 availability zones. Multi-AZ isn't optional. It's how you survive a data center failure. Concept 3. Route tables, and this is where the real answer lies. Every subnet is associated with a route table. A route table is just a list of rules that say, for traffic headed to this destination, send it here. Every VPC route table has a default local route, which lets all the resources inside the VPC talk to each other privately. That's automatic. Now here's the key insight of this entire video. If you add a rule that says for destination 0.0.0.0/0, which means anywhere on the internet, send the traffic to the internet gateway, then that subnet's resources can reach the internet. And that, and only that, is what makes a subnet public. It's not a checkbox called public. It is entirely determined by the route table. Concept 4. The Internet Gateway. The Internet Gateway, or IGW, is the component you attach to your VPC to give it a door to the public internet. It's fully managed by AWS, highly available, and scales on its own. You don't size it. It allows traffic in both directions for resources that have a public IP address. But here's the catch that trips people up. Simply attaching an internet gateway to your VPC does nothing on its own. The gateway and the route work together. You need both. Concept 5. Public versus private subnets, and the definition interviewers want. So let's state it plainly, because this is a favorite interview question. A public subnet is a subnet whose route table has a route to the internet gateway. A private subnet is one that doesn't. That is the entire difference. There's no magic setting called make this subnet public. It is purely a consequence of the routing. So in our architecture, the load balancer, which must accept traffic from users, goes in a public subnet. The application, servers, and the database, which must never be directly reachable, go in private subnets. Same VPC, different route tables. Concept 6. The NAT Gateway. Here's a problem. Your application servers are in a private subnet, so they are safe, nobody on the internet can reach them. But they still need to download security patches or call an external API. They need to reach out without being reachable. The solution is a NAT Gateway, which stands for Network Address Translation. You place the NAT Gateway in a public subnet where it can reach the Internet Gateway. Then, in your private subnet's route table, you send 0.0.0.0 so 0 traffic to the NAT Gateway instead of the IGW. Now your private service can initiate connections out to the Internet and the responses come back, but nothing on the internet can ever initiate a connection in. It's a one-way valve. One warning for real projects: NAT gateways are not free, and they are a common source of surprise AWS bills. Concept 7. Security Groups versus Network CIDR, the two firewalls, and a guaranteed interview question. AWS gives you two firewalls, and knowing the difference is a guaranteed interview question. First, the security group. It acts at the instance level, wrapping around your server, and the crucial property is that it is stateful. If you allow traffic in, the response is automatically allowed back out. You don't write a rule for it. Security groups only support allow rules. You cannot write a deny. This is your primary, everyday tool. Second, the network is CL, which acts at the subnet level, protecting everything inside it, and it is stateless. That means if you allow traffic in, you must separately allow the response back out. It does not remember. But unlike security groups, NACLs support explicit deny rules, which makes them the right tool for blocking a specific malicious IP address across an entire subnet. Remember it as security group instance, stateful, allow only, NACL, subnet, stateless, allow and deny. Concept 8. Let's put every piece together into the architecture you should be able to draw from memory. Here's the architecture. In each availability zone, you create 3 subnets: a public subnet, holding the load balancer, and the NAT gateway, a private subnet, holding your application servers, and another private subnet, holding your database. The flow is this: a user's request comes from the internet through the internet gateway to the load balancer in the public subnet. The load balancer forwards it to an application server in a private subnet. That app server queries the database in its private subnet, and when the app server needs to reach out to the internet, it goes via the NAT gateway. The database is never ever reachable from the internet. If you can draw this diagram and explain each arrow, you could answer almost any AWS networking question. Concept 9. Best practices that show real experience. A few practices that make real experience. Always span at least 2 availability zones, so a single data center failure doesn't take you down. Plan your CIDR ranges carefully up front, and never let them overlap with other VPCs or your office network, because overlapping ranges make VPC peering impossible later, and that's painful to undo. Put only genuinely internet-facing things, load balancers and NAT, in public subnets. Everything else goes private. In your security groups, apply least privilege, and rather than allowing wide IP ranges, reference other security groups. For example, allow the database to accept traffic only from the app server's security group. And finally, watch your NAT gateway costs and use VPC endpoints to reach services like S3 and DynamoDB privately, without going over the internet at all. Said simply, a VPC is your private network, and route tables decide everything. Draw the 3-tier diagram and explain security group versus NACL, and you've shown you truly understand AWS networking. And that's the AWS VPC end-to-end. Your own isolated private network, sliced into subnets that each live in one availability zone. Route tables, and route tables alone, decide whether a subnet is public or private. An internet gateway is the door in. A NAT gateway is the one-way valve out for private servers. Security groups are your stateful instance firewall, and network CLS are your stateless subnet firewall. Put it together as a 3-tier architecture across 2 availability zones, with the database safely private, and you have the design that underpins most real systems on AWS. If this helped, subscribe for more. Thanks for watching, and good luck in your interview.